Okay, Martin, I think we'll start the broadcast now.
The broadcast is now starting. All attendees are in listen-only mode.
All right. Hello, everyone, and we're just going to give everybody a couple more minutes to join us here, but I just wanted to thank you, everyone, for the ones that have joined us already, and just bear with us. We'll start in a couple of minutes. All right, well, maybe we'll get going here so that everyone can get to their lunch. So hello, everyone, and welcome to our first ever Western Canadian Organic webinar series. I appreciate everyone giving this a chance and joining us today. So to start things off, I am Chantal Jacobs, and I work here in Regina for Saskatchewan Agriculture. And I'd just like to say, way to go, riders. I don't think I've ever seen Regina that green in November, and it was just a great weekend had by all. So I hope everyone had a chance to check the game in a nice, warm spot. And so today I will be your chair for the webinar. And I would also like to thank my colleagues Laura Telford with Manitoba Ag and Carrie Sharp with Alberta Ag for helping make this series happen. They provided a lot of great ideas and thoughts going into this. So today's presentation will be our first webinar in a series of 6 that we're hosting this fall and winter. And our next webinar is actually scheduled to be over the lunch hour on January 28th. And that one, the topic will be on improving organic weed management. So moving into our presentation today, we're expecting it to be about an hour in length or so, and we'll have lots of time for questions at the end. You guys all are muted right now, so if you're trying to ask a question and it's not getting through, you're muted, so I apologize. We won't be able to hear you, but feel free. There's a chat box in the bottom right-hand corner of your screen, and type your questions in there. And at the end of Martin's presentation, he'll be sure to address those questions and get the answer to you. If you are viewing the webinar today from a computer with dial-up, you may experience just a slight delay in the audio or the slides. Again, the webinars will be recorded, or it is being recorded right now. So if you have any issues, you need to step away, or your internet connection goes out, you will get a link that'll take you to the recording after the presentation. So that should hopefully help you out and catch anything you might have missed. And on our end, if we get technical issues over here, you never know, power might go out, who knows. Just stay online and we'll reconnect as fast as we can. So just bear with us. These systems can work very well when things are going the way they should. So, all right, I think that's it for me. So at this point, I would just like to extend a very warm winter welcome to our presenter, Dr. Martin Entz. Dr. Entz is a highly respected professor who actually leads a natural systems agriculture research program at the University of Manitoba. And, as an example, his research looks at complex crop rotation systems and the various effects they have on soil fertility and weed competitiveness. He looks at a wide range of things that wouldn't be doing it justice to try to capture it here. So if you're interested in finding more out about his research, just enter in into a Google search, just enter in natural systems agriculture, and it should take you to his main extension website there. So I don't take up any more of your time, Martin. Just without further ado, a warm welcome from all of us here today, and I guess take it away.
Okay, thank you very much, Chantel. And yep, congratulations to the Rough Riders. And hello to all of you listening in from wherever you are. It's a real pleasure to be involved in this webinar today. And the topic that I'm decided to talk about is designing organic farming systems using nature's processes. And before I go any further, I'm actually going to use the cursor here to sort of draw a circle around my research group because this is, in fact, a team effort. And that's one of the real fun things about my job is I get to work with lots of different people. And I'll introduce you to some of them right here. That's me in the middle in the really odd shirt. This is Keith Bamford here on the right. He's our senior technician, and he's a very, very good farmer, and he's responsible for a lot of our very good organic yields. He's added a lot of knowledge. He's gained a lot of knowledge, and he's been doing organic farming for 20 years, and hopefully some of you will be able to come to our field day this summer and walk the plots with Keith. Over here we have Joanne Thiessen-Martens, who's also with my group, has been for many years, and she works on the crop livestock integration, part of our research, and also helps with extension. And here's a number of graduate students and summer students in the picture. So I want to shout out to them for all the wonderful teamwork that we experience here. The themes today are really just two sort of nature's processes and one surprise. I've got a surprise for you later on in the webinar. But I'm going to talk about diversity and nutrient cycling. Those are two very, very important processes that we rely on in organic agriculture. And we have to always think about how to organize them, how to manage them to our greatest benefit. Okay, before I've switched to the next slide here, and before I talk about these processes, I want to emphasize a little bit on the profitability of organic farming. And so what we've done at the University of Manitoba is we have established a small organic farm at our Carmen Research Center, and this little, we call it the farmette. We call it many things. The Organic Crops Field Laboratory, whatever. But it is something that Keith and I put together after sort of 10 years of work on organic farming, and we decided we would like to try to put the best agronomic practice, put in the best rotation that we thought was adapted to this particular area of Canada. And so we set up this biodiverse cropping system, which has a green manure every third year. So as you can see from the slide, it starts off with a green manure, then goes to spring wheat, then soybean, then a green manure, then flax, and then oat. And we ran this system for 7 years, and then colleagues in the agricultural economics, agribusiness department did the economic analysis on this. And I thought I would start with this because it kind of sets the stage for, questions like, is organic farming profitable? And how might these diverse crop rotations work? So I'm going to walk you through some of the outcome of this experience of this organic farmette. and show you our 7-year average yields. And so what you should be seeing is a picture of a number of different crops, and Iris Faisman is up on the top left, and Ann Kirk is on the bottom right, standing in front of some soybeans. And the plots in our experiment were 2 acres in size, and we harvested them with commercial equipment and then dumped all the grain into a weigh wagon and weighed it. So it wasn't just based on a square meter or a few square meters of yield. And over the 7 years, Keith, through his superior farm management, was able to grow 48 bushels per acre average yield of spring wheat. Our flax yields averaged 22 bushels per acre, and you can see by the picture that we've actually no-tilled the flax. And the way the rotation works is we grow hairy vetch, barley, green manure. We use a blade roller and then create this mulch, and then zero-till the flax into it. And after the flax, we seed the oats, and the average oat yield is 72 bushels per acre, I should say. We had one very bad year right at the beginning, very low oat yield, and that's because we planted a variety that was not crown rust resistant, and that was a lesson in variety selection. And then our 7-year average organic soybean yield is 29 bushels per acre, and we grow our soybeans in 18-inch rows. We do pre-emergence harrowing, we do post-emergence harrowing, and we do in-crop cultivation. So these are the yields that we've achieved, averaged over 7 years. These aren't just the highest yields, these are the 7-year average yields, and this document showing these yields is on our website. So what we wanted to look at then is the economics and the cost of production and all those things. But before I do that, I'll just show you a few more pictures. This is the flax seeded into the hairy vetch mulch, barley mulch that was rolled, and the flax was zero-tilled into here. So one of the questions, I've got a few questions inserted into the webinar that I like to ask myself, and I know that often come up in conversation with farmers. Is, for example, are organic farmers using more diesel fuel? And the answer is not necessarily, because we're starting to see these, short-term no-till systems come into organic farming. Okay, so back to the 6-year crop rotation and the 7 years of data. What I'm showing in this graph is the returns per acre. And I've just highlighted the pea oat part of the rotation first of all, because the results can either be really bad or really good, or better. What we have here is for the organic system where we do not graze the pea oats, it's costing us $168 per acre to grow that crop. So, and there's no income that year. If we take that crop and graze it with livestock, we actually, according to our agricultural economics colleagues and their expert analysis, we made $30 an acre. And that's a really important thing for us to think about, because we know we need green manures in organic farming systems. And in fact, there is a tendency to kind of avoid using green manures because there's no income that year. Well, if we graze them, like in this example, we can make that green manure profitability go from minus $168 an acre to plus $30 an acre. And I just wanted to show you some other, more, we call it the grazed green manure math. Joanne put this together. And to show you the potential income from grazing something like you see here on the left, a pea oat mixture, or on the right, there's a soybean crop being grazed by the sheep. If we produce 5,000 pounds per acre of this green manure biomass, which is very possible pretty well everywhere in the Canadian prairie region, And then we assume 50% of that above ground biomass is utilized by the animal. That gives us 2,500 pounds per acre of dry forage. If we look at a feed conversion of 0.07, that gives us 175 pounds of live weight gain per acre. And that's where the value of the grazed green manure comes from. And then what we've also learned through our work is when animals are grazing the green manures, we've looked at the following crops and asked the question, does grazing the green manure reduce the nitrogen available to the following crop? And the answer is no. In fact, sometimes it increases the amount of nitrogen available because the rumen processes the biomass faster than the soil does, releasing nitrogen. I wanted also to kind of pause here and just show you some pictures of different types of green manures because, well, here we have a very standard species mixture, forage pea with oat. This grows extremely well. It's well adapted to many different growing conditions. For people in drier areas, there's a whole bunch of choices of green manures which work really well. Chickling vetch, for example, it goes under the variety name of AC Green Fix. Here it is growing at Carmen, drought tolerant, highly productive, excellent nitrogen fixer. In wet soil conditions, like this picture from the Red River Valley of Manitoba, something like faba bean is a very good choice because it can handle wet feet, it can handle wet growing conditions and still fix a lot of nitrogen. And then we have another very widely adapted green manure species, and that is hairy vetch, which grows well right across the prairies. And it is something that we've only started working with about 7 years ago, but are finding it to be an excellent contributor of nitrogen. And sometimes farmers find themselves not being able to plant until the beginning of July, and things are really hot. And there are tropical legumes like lablab that fit into our farming systems. And that's the plant you see in the middle of the plots. On the right, there's a plot of cowpea, another tropical legume. So we have legumes, green manures that we can grow in very hot conditions. And then this is the legume mixture that we like to grow at Glenlee. We call it our weatherproof mixture. It's got peas and soybeans and faba beans and oats. So the peas will grow well if it's dry. The soy and the faba bean will grow well if it's wet, and they can handle some temporary flooding. And the oats, well, they do well under most conditions. So I've kind of interrupted the economic analysis just to show you some different green manure species, because it's always important to think about what green manure species I'm going to plant, and all of the ones that I've shown you there are grazable. Okay, so now here is the table, the figure of the returns for the entire crop rotation. So just to remind you, I'll use my mouse here and I'll show you the crop rotation. We start off with a pea, oat, green manure, then we go to spring wheat, and then to soybean, and then to barley, hairy vetch, green manure, then to flax, and then to oats. And in black is actually the crops that we grow at our research farm during the same period, and we compared the economics of that. We grew canola, we grew oats, we grew flax, and we grew wheat. And the net returns here, well, we've talked about the green manure. It's $30 if we graze it. If we look at the wheat crop, we're making $215 an acre organically, whether we've grazed this or not. We're making $33 conventionally. Soybean, $317 an acre profit. We didn't grow any conventional soybeans. Here again, we have the barley hairy vetch green manure. It's costing us $166 an acre. We're not grazing this green manure because we're using it to create a mulch so we can zero-till the flax and hopefully zero-till the oats and reduce some fossil fuel use. So we're having to invest that much money in the system. If we look at our flax, $357 organically, $168 conventionally. Oats, and then we've got conventional canola making a healthy profit over this 7-year period. So this gives us some idea of, which crops are providing which net return, and really reminds us that the green manures, even though they're expensive, they're important, and if we graze them once in a while, we can reduce the cost of them. The next slide here shows the number that we're really interested in, and that is the net return. The previous slide showed the total return. And so we can see here the conventional system is at $153 per acre net return. The organic without grazing is at $111, and the organic with grazing is at $144. So really all 3 production systems were profitable, which is good news. The organic system required less investment to make the money. It's $185 without grazing, $204 with grazing compared to $230 in the conventional system. So the conclusion of our work is that, the organic system is not completely out in left field. It's making as much money. And I'm going to start with this slide first. It actually shows the cost of production of wheat during this period in the red line, and it shows the price that we were able to get out of the organic marketplace. And one of the things about this analysis that I've just gone through with you is that it was during a period of time where organic prices peaked and then really crashed. So I like to use this example because it shows what happens when organic prices are not through the roof. They're really very, very modest. And even under those modest price conditions, the organic system was profitable, and that's good news. In terms of the cost of production, just a very interesting comparison to the conventional, our wheat cost of production in 2011 was about $4 a bushel in this system. Okay, now I'm going to go to the conventional wheat, and you can see this is the price that we got for the conventional wheat. It was also quite low, but the cost of production for the conventional wheat is closer to $5. So it is interesting to note that the organic wheat we're producing it in this system at about $4 a bushel. The conventional wheat here is costing us probably more like $4.80 a bushel. Okay, there may be some questions later about this economic analysis, but one thing that we've learned from this experience, which is still going on at Carmen, is that the profitability of organic farming is possible even through some fairly lean organic price premium periods, and it depends on, I would say, number one is farm management skills. This is so important to the timeliness of operation. Not being an absentee farmer is just not possible to grow good organic crops without visiting the fields often and being there and doing the interventions. Number two, a biodiverse cropping system. And on the bottom right of the slide, you can see the rotation. This is the type of rotation that has a chance for success. Green manure every 3rd year. That adds lots of nitrogen into the system, and so the wheat and the flax and the oats are not nitrogen limited. And then livestock integration. That grazing of by the animals really makes a difference in terms of improving the profitability. And that's a challenge for a lot of farmers, right? You may not have livestock, you're not interested in livestock. Well, how do you deal with that challenge? Maybe you can work with a neighbor. Maybe somebody in your community wants to get in the livestock business but doesn't own any land. So there's all kinds of interesting opportunities. And the fourth thing that made our system profitable is the blade roller, the novel tillage reduction tools. Okay, so that's sort of part one and an introduction to the webinar. Now that we've convinced ourselves, or at least I've convinced myself, that organic farming is profitable, I want to focus on these two, or continue talking about these natural processes. Clearly, diversity is an important one, and that's what made that rotation profitable. I want to focus now a little bit more on soil nutrients. And this Glenlee rotation study that we've got running is really a very good place to do this kind of thinking. And in fact, I like this quote here: "The years teach much, which the days never know." You know, when it comes to fertility, it's hard to turn on a dime when you're farming organically. You need to, the fertility management of soil is a long-term management process. Okay, just very quickly, I'll show you some of the crops at Glenlee. We've got a rotation that has only grains, and then we've got a rotation that has 2 years of alfalfa and wheat and flax. So this is our grain-only rotation. We've got our GM, doesn't mean genetically modified. It means green manure. So we have a green manure crop, and you can see it's been disked here. Then we have wheat. There's our wheat crop. And then we go to flax, and then we go to oats. And Glenlee has been running for a number of years. I just wanted to show you what the crops look like. This is our organic wheat in the grain-only system back in 2009. And Marc Belanger is on the left. He's an organic farmer from west of Souris, Manitoba. And he has with him a visitor from Germany who's actually a food retailer buying organic grains out of Canada. Here's another picture of our organic wheat. This is now in the 21st year of the rotation. This is in 2012. And you can see that, you know, the crops continue to look good. And this is the organic wheat last year. We've had 2 dry years, but the crops were okay. We've improved our management over time. Our wheat yields have gone up. One of the things that we started doing 2 years ago is cultivating between the rows of our grains, and that's made a big difference. So you know, there's so much wiggle room in terms of the management of the crops to bring up the productivity, and I think that's exciting. Now, in terms of the long-term productivity and the soil fertility, let me tell you the story. This is the wheat yield data from Glenlee, and before 2005, where that line goes up and down, before, you know, right here, our forage grain system, our organic forage grain system, was always out-yielding the wheat in the grain-only system. And, you know, that kind of makes sense because the forage is, you know, killing wild oats and Canada thistle and adding nitrogen. So if we look at 2003 here, you can see on the left we have the flax in the grain-only organic system, and on the right-hand side we have the flax in the forage grain organic system. And, you know, day and night, and clearly the crops in the forage system looked much, much better. But then after 2005, you know, things kind of changed. And if you look at the diagram, that solid blue line there is our forage grain organic system, and it's kind of fallen behind. There is our grain-only forage, grain-only organic wheat yield, and it's yielding better. And you know, what was going on there? Well, what was happening is we were running out of phosphorus. And in fact, this green line here is when we started adding manure into the farming system, and we quickly restored the yield potential of that organic wheat in the forage grain system. Okay, let me show you some pictures of what it looked like. This is a field of alfalfa with some grass in it. This is the plot, and the front half had received a little bit of composted beef cattle manure. The back half has never received any of that manure. This picture was taken about 17 years after we started the rotation. So if we look at that black forage field, you know, it was seeded with alfalfa, but because the phosphorus level is so low, the phosphorus is not growing very well anymore. And that's why that forage grain system had failed. So I like farmers to come visit these plots, and I would invite you to come to Glenlee this summer And I will take you on a tour of these plots because this phenomena occurs every year. And it really tells us something about how to manage fertility in a long-term organic system. Now, of course, you've already figured out what the problem is. If you can't grow any legume in that forage phase, then the organic system is going to run out of nitrogen because, well, the story is you've got low phosphorus, which means no nitrogen, and so then you have reduced yield of your nitrogen-requiring crops. So manure recycling, nutrient recycling is very, very important. Manure is rich in phosphorus, potassium, sulfur, micronutrients, and carbon. And so it is a very important part of a long-term sustainable organic system. And before you sort of go, oh my, I can't do this, there's no livestock within 100 kilometers of my farm. Well, just hang on. There's there are some other options, but I think looking for manure is a very good idea. But let's take a closer look at this phosphorus deficiency phenomenon. Okay. And so in this next slide, I've shown you sort of the stock of phosphorus. On the left is the conventional high-yield system. This is what the phosphorus looks like in your soil. The blue part on the top is your available phosphorus. This is what the soil test measures. And then you have a much larger pool of phosphorus, which is not measured by the traditional soil test, and it's called the residual phosphorus, or in this paper we called it the recalcitrant phosphorus, but I can't really say that word, so I just like to say the residual. It's easier for me. And you have this large stock here. Now, in the organic system, if you were growing just grains and green manures, your system wouldn't look quite like this. You'd have more of this available phosphorus. But in our case, where we were exporting a lot of alfalfa hay off that rotation for, 20 years, we really reduced that available phosphorus quite a bit. So our soil tests are down to 3 parts per million, 2 parts per million, 4 parts per million. And so that raises a lot of questions, right? How do you approach this? Well, one of the things, I've just hit the insert button again, and one of the things that I've shown here is the mycorrhizal spores in the conventional and in this organic soil. And these are real samples from Glenlee, and it shows that where we manage soils organically, we have a lot more mycorrhiza going on. We've got a lot more phosphorus solubilizing bacteria in the soil. And so, we wonder about, well, maybe we don't need to add any phosphorus because we've got all these mycorrhiza, and they can get this residual phosphorus and bring it to the plants growing in this system. Okay, those are questions, and we have some answers to those questions, but there's still a lot of unknowns, and we have to be careful not to take unnecessary risks. Our conclusion from our experience at Glenlee and also watching organic farmers is that there is a time and a place to be adding manure, preferably composted manure, to your lands so that the phosphorus situation doesn't become quite as dire. But we also know that farmers can have low levels of available soil phosphorus and still grow very good crops. So there's a lot of unknowns. My personal feeling is that adding manure on a once every 10-year basis is a very good insurance policy. Now, when it comes to adding manure, whether we need it or not depends on the soil phosphorus levels and the type of crops that you grow. So if we look at this next picture here, at low soil phosphorus levels, you can see the wheat at Glenlee really needs that manure. The back part of the plot has had manure added, the front half has not. And you can see the crops are very, very different. They're clean. There is no wild oats in there. There's not much Canada thistle. That's what happens when we grow wheat in this very nice alfalfa wheat flax rotation. But we do need a little bit of manure added back to that system. If we look at flax, this is flax, a picture I took in 2013. that flax there and this flax here, they look very similar. And at low, very, very low levels of soil phosphorus, we don't find any response of flax to the composted manure. And, you know, I'm going to have a little contest. Which half of this plot that's in front of you do you think has been treated with compost? The front half or the back half? What do you think? Well, there's the answer. The back half has had no composted beef cattle manure, the front half has. And you can see all the manure has done is actually has made the weeds grow better. But so it depends very much on the crop. You might be saying, well, why don't you give us a recommendation, Martin? We want something to work with. Well, you know, I've given this a lot of thought over the years, and I think it's a very good idea to plan to add manure to the field at least once every 10 years. And it doesn't have to be a lot of manure. The manure should be added just to satisfy the phosphorus deficiency. Don't add manure to satisfy the nitrogen deficiency, then you'll waste all your manure because you can grow the nitrogen with your legumes in a good rotation. So you need a good manure spreader that can spread low amounts of compost across the field once every 10 years for most farms. That would be more than enough. And I do want to stress that I feel it's important to add compost and not compost tea. There's actually quite a bit of research that's been conducted around the world, including in Canada by the Organic Ag Centre of Canada, that shows that compost tea really does very little for soil fertility. And it does make sense because the tea really doesn't contain a lot of nutrients. It contains some, but what you really need is compost. So that's my recommendation for manure management. And in summary of the fertility question, here it is on the slide. Nitrogen, usually not a problem because we can grow that with our legumes. If we skimp on legumes, then that's going to be a problem. Phosphorus and potassium, P and K, can become limiting. If we have a very intensive hay removal system, it can take 10 to 12 years and we'll start seeing reductions in soil phosphorus. That's what we saw. And then by 20 years, it's looking pretty grim. In a grain-only system, though, I've seen systems that are 20 years old. People have been growing organic crops, and there's still really no reduction in phosphorus. In fact, in some cases, the phosphorus levels have come up because the green manures are bringing unavailable phosphorus into the available form. But we need to plant and soil test so that we know what our status is. Composted manure is probably the best nutrient source. Apply at low rates, really only for phosphorus, not for nitrogen. So you can apply, 1 ton per acre. There are manure spreaders that go that low, and so you can cover a lot of acres and keep it affordable. And look for cheap nutrient sources and keep it simple. This next picture just shows a couple of simple ways of getting nutrients onto organic land. On the bottom here, you've got your farm feedlot. We can spread the manure, spread the compost like we've been talking about. And another way is to bring in bales, bring in hay onto the farmland, have the animals process it in the wintertime when they're just hanging around doing nothing. Your land is not being used for anything. Might as well do some fertilizer placement. So these are all options that I think should be considered, and I would encourage farmers or farm advisors to very carefully calculate the cost of a pound of phosphorus, the cost of a pound of sulfur when you're looking at various fertilization regimes. Like I say, there's still a little bit unknown on phosphorus, and Derek Lynch at Dalhousie University is working on this phosphorus stuff at the Glenlee plots, and Mario Tenuta from our soil science department is also working on the phosphorus. So I think more knowledge, more information should come out in the next few years. Now I want to go back to this picture because, because it's a very interesting story, the connection between soil fertility and weeds. What we have in the foreground is, you'll remember, this is the flax where we've added the compost, and you can see the non-mycorrhizal weeds, the mustard, which can't get phosphorus out of the residual pool because it doesn't have these mycorrhizal fungal connections. And so it likes the compost. Over in the far end of the plot where the level of available phosphorus is lower, you can see there's better weed control. And so this is kind of the dance that we have to learn is how little compost can we get away with to stimulate the plants to grow, but not stimulate too many weeds. So this is something that we at least need to be aware of in our farming system management. And at Glenlee, we have certain weeds that have disappeared from the organic system, like redroot pigweed, which does not grow well under low available phosphorus levels. Bob Blackshaw at Agriculture Canada in Lethbridge has demonstrated this through his scientific research, and we've actually seen that weed is no longer a problem at Glenlee, and it's kind of interesting to observe that. Okay, I want now to get you to focus on that picture on the upper right, and it shows a black and white photo of some poor summer student whose job it was to go dig these roots out of the soil, and thinking about the structure of that soil, because this is a question that's really important in organic farming. It's not just the fertility of the soil, it's also the structure. Is it going to blow away? Is it going to wash away? And the column right to the next of the picture is, this is basically the wet aggregate stability, or the larger the number, the more stable the aggregate of soil is, the more resistant it is to washing away with water. And what's quite interesting, and these soils are from Glenlee, is the organic systems have higher levels of soil stability than the organic system, than the conventional systems. Especially the grain-only conventional, even though we're adding all those fertilizers and doing all that stuff, we're getting much lower levels of soil stability than when we go organic. Now, how can that be? And it's a good news story. We should all everybody give yourself a pat on the back. Come on. Have you done it? All right, good. Okay, you can stop now and I'll pay attention. And so everybody can feel good about that. But how does that happen? Well, the reason it happens is because the organic soils have more of these mycorrhizal beneficial fungi living in the soil. And you can see the data on the right shows that there's a correlation between, you get low mycorrhiza, you get low stability, and the higher the mycorrhiza, the higher the stability of the soil. And of course, the prairie gives you very high mycorrhiza, and we didn't measure the stability. And this is an interesting observation because it sometimes organic farmers are criticized for, having soil exposed and it's tilled. Well, in fact, in our experiment, it actually has greater stability, greater erosion resistance, and that's because it's more biologically active with these fungi. And so here's another question that sometimes comes up, and you might think it's a very bizarre question to be inserting at this point in the webinar. Are organic foods healthier? Well, the answer is, and there's lots of good data on this, usually they are. And it's because the organic soil has a higher level of soil microbial activity, including mycorrhiza, and this means there's more micronutrients coming into the food, and that's one of the reasons they're healthier. So I just like to throw these questions in to get us thinking. So by keeping our available soil phosphorus low, which keeps our mycorrhiza higher, by emphasizing organic phosphorus sources like composted manure, we promote mycorrhiza. Basically, we build microbial biomass carbon in organic systems, and here is our data from Glenlee. These are our forage grain systems. We've got our conventional system over here, and look at our two organic systems. Whether we add manure or whether we don't, we have higher levels of microbial biomass carbon in the organic systems versus the conventional system where we're adding all those fertilizers. And this red line is the microbial biomass carbon in our prairie plots. So clearly the organic system is statistically significantly more alive than the conventional soils. That's the story. And so the final question in this little list of questions is, are organic farmers causing soil carbon to decrease? Well, one thing that we know is exactly the opposite is happening. Organic systems have more active carbon. Even if sometimes they have less total carbon, they have more active carbon. And that's exciting to me, and I think that should be exciting to you. There's something going on in the soil that is making it, there's a greater buzz, there's greater life in the soil. And in fact, there's a large analysis by Andreas Göttinger who looked at soil organic carbon in organic and conventional systems around the world and came to the same conclusion. Okay, so that's a little bit about our about the soil fertility. I'm going to go through some of these slides because I really want to leave time for questions, but I want to focus on one other natural process. This is the one that, you know, is kind of a surprise. But I'll tell you why I came to this place in the seminar. Over on the left here, this is an organic field day. This is out at Oxbow, and you know, there's a farmers listening and everything. And I often wonder, you know, when they leave the field day and go to their, you know, organic grain farm or their small-scale organic integrated farm, you know, what do they do with the information? How are organic farmers adapting to change? Because they're all going to, you know, everybody experiences change, and whether it's weather or prices or whatever. So the final natural process that I want to emphasize is the process of thinking. Yeah, thinking. These farmers here are all thinking about things, and that's such an important process because we're always faced with challenges, and in conventional agriculture, we don't have to spend that much time thinking. We just pick up our BlackBerry or our iPhone and we dial, you know, 1-800-Viterra, come fix my problem, and then we write a check. Okay? In organic farming, we can't do that. So I like to just use this adaptive learning model that Buzz Halling, who's actually a Canadian, came up with. And I'll show you, I'll try to explain how it works. So you start over here somewhere and you exploit a new idea, maybe organic farming, and then you come to what's called the conservation phase. You have a system that's working perfect for your farm. And then all of a sudden something changes, the weather changes, the markets change, your phosphorus changes, and you have to release away from some of your ideas and sort of reorganize yourself and then take another stab at your problem. Okay? I'm assuming that makes sense to you and you can follow that. And now I'm going to show you the same model with just a little sketch diagram that we recently published in a book chapter. And this is exactly on organic farming. So I hope you can see my cursor. See, it's over here. You can see it wiggling around. So you're a conventional farmer. You've seen some on-farm organic trials. You decided to go organic. You go through the certification period, and then you come up here to this area where we call it conservation. You've got a successful, stable system. Everything's going well. And you do make changes in your stable system all the time, and in response to little problems. You might get a better harrow for weed control. You might get a better disc to incorporate your green manures, etc. But then all of a sudden, something big happens. You know, you have the loss of system stability for some reason. You've got an unfamiliar challenge. Maybe the crop that you were relying on to make your money, the market falls away to nothing, and so you need to grow a new crop. So you need to, you know, release from those ideas and sort of, you know, renew, reorganize, develop new practices, develop new ways of thinking, and then apply that new knowledge, gaining insights, gaining skills, and then bring that back into your successful system. Perhaps of all the processes that we talked about today, this process of thinking, no surprise, it might be the most important, because how organic farmers respond to their problems and then release away from that, pick up new practices, and then apply those new practices to their farming system, it really is critical to the success of the operation. And of course, one of the ways of doing this is to talk to other organic farmers, is to go to conferences, to learn new things. Maybe this webinar is a small help. I certainly attend the other webinars, that type of thing. So in summary then, the three processes that I wanted to emphasize are nutrient cycling, biodiversity, and thinking. And so with that, I will end the webinar and I will turn it back over to Chantal.
All right. Thank you, Martin. So that was a great presentation. And we do have some time here for questions. It's about 10 to 1. So I've got a couple already in the queue. One from Greg Ferris. I should say, for folks on the line, please enter your questions in either the questions or the chat area at the bottom right hand of your screen. I see one fellow, I think it's Chuck, had his hand up, and if you could just enter in your question into that area, Chuck, that would be great. So anyways, in the meantime, Greg Ferris has a question. Do they track the protein content of wheat in your rotation?
The answer is yes. Very important because it tells you something about the nitrogen supply of the system. And yeah, I'll just leave it at that.
Okay.
And perhaps he wants the results. And one of the things that I would say is in the forage grain wheat system, the protein is always high, very high, like above 15. In the system where we have the green manure and then wheat at Carmen, same thing. The protein is always very high. The only place where the protein is a problem is if you're growing a crop 3 years after the green manure. If you stretch that rotation, so you have a green manure, then let's say wheat, and then flax, and then oats, that oat crop might have low protein, and that can be a problem in some markets. And that's why having a green manure every third year it will guarantee high protein.
Mm-hmm. Great. As we wait for a couple more questions to come in, Martin, I often get questions about, is it better, some guys, they say, I leave basically a green fallow as the green manure, and then, I don't actually seed anything specific, but I let it grow up, and then, the different diversity of weeds that come up and that, I plow that in, and they feel that provides, a good benefit to their next crop, soil moisture and whatnot. How do you feel on that one, as far as seeding a specific legume as or a legume cereal mix as your green manure versus letting the background weed population grow and then plowing that in?
Well, I think the background weed population idea is a problem, and it's not a good idea because you're not adding nitrogen. Mm-hmm. And it may be a good idea in 1 year, but in the long term, it's a bad idea. And what it does is you might grow a high-protein, high-yielding crop after that, but you've tapped into the organic matter of the soil to do that. Mm-hmm. And so the way I look at it is by adding a legume into your fallow period, you're actually putting money into your checking account and leaving your savings account alone. And then your wheat crop the next year is growing its protein out of that checking account. If you don't put the legume in, you've put nothing into your checking account, and all you've got left is your savings account, which is your soil organic matter. So that's a practice that has serious sustainability problems. I hate to be so blunt, but it needs to be said.
Mm-hmm, mm-hmm. Good, thank you. We have a couple more questions. Greg has also asked, does it matter when the compost is added into the rotation?
Not really. The compost, in a situation where you have, let's say, a forage crop, and then you're following it with grains, what we do, we actually add the compost during the forage years, because the compost is always going to cause some weed seeds in the soil to germinate, because now they have some nutrients that they might have not had. and we can deal with those weeds very nicely in a hay field or in a pasture field. But if you add the compost, let's say the year before the wheat, then you're going to have more weeds in your wheat. So that's a consideration. But in terms of trying to time the compost to deliver the nutrients to that crop, nutrient availability from compost is extremely slow. It's something that you do for the long term, and but it doesn't really matter when you do it.
Okay, great. We also have one in from Ken. He's asking, have you done comparisons with green manure, plow down, and wheat or barley in a 2-year cycle?
We haven't worked much with barley, unfortunately. I think the green manure is really important for the wheat because we're growing it to produce high protein milling wheat. I think in a rotation, I would think barley would be a better crop to go after wheat, simply because it doesn't require quite as much protein. And for malting, definitely not. And it's also a bit more competitive with weeds. So that's where I would put it in the rotation, where it doesn't need as much weed control or nitrogen.
Okay. He just added in just that his, for example, going wheat, green manure, wheat or barley, and then a green manure, and then barley as an examples.
Yeah, putting barley after a green manure is, it would make the barley crop grow better for sure, with more nitrogen and higher yield potential. So green manures are always a good idea, but I can't really compare wheat or barley because we haven't done that work.
Okay, fair enough. Got another one in here from Chuck, so I'm glad he had a chance to ask his question. He said, you mentioned you used beef manure. Would chicken manure work? Oh,
yeah. Poultry manure is actually richer in nitrogen. And if you just type into Google nutrient content of different types of manure or compost, you'll get lots of good provincial government sites with sort of the average numbers in them. Poultry manure is fine. In the U.S., a lot of organic farmers buy compost, and it's also pretty common in Eastern Canada. And then they call it turkey cluck. Turkey compost is very rich in nutrients and is actually a desirable source of the nutrients. But I think, again, whatever, you got to remember to get the cheapest source for your you got to be careful how much you're paying per pound of phosphorus.
Mm-hmm. Right. Great. Well, we have a couple more minutes here. If folks have one final burning question that they'd like to ask Martin before we head out. And I'm just scrolling through here to see if there's any last trailers to come in, but it looks like it's pretty quiet on the audience. Seems pretty happy, or they're busy chewing on their lunch. So I guess I'll do a wrap up here, Martin, and I'd like to thank you again for the wonderful presentation. And I'm sure if folks have questions that come up, some of people weren't able to attend right now, but they were planning to view the recording after when they got back. So if there's any questions that come in, I'll make sure to pass those along to you, or maybe they'll get in touch directly. So I guess I'll just like to thank everybody for taking the time to join us over this lunch hour. And, I guess I'll mention there is a short survey after you exit our webinar today. We will treat every answer, all your answers as confidential. Just because it's our first one, we're really asking just for some feedback, even ideas on who you'd like to have present in the next year or so. So. And of course, a reminder that our next webinar in this series will be on January 28th, and that'll be a focus on organic weed control. So, thanks again for your time, Martin, and we greatly appreciated that presentation. It was really informative, and yes, thanks again.
Happy. It was my pleasure, and I wish everybody a wonderful day.
Yes. All right. I'll be closing it off now. So everyone have a great day, and thanks again for joining us. Take care.